Okay, this is the second part of 1.1, Introduction to Graphing. Okay, so in the previous part, we kind of became a little bit acquainted with the rectangular coordinate plane. Points can be represented with coordinates, the axes, quadrants. We graphed linear and nonlinear equations. Let's look at a few more little things about more aspects of graphing in the rectangular coordinate plane. First of all, let me mention there is, you might have heard about this, you might not, but let me make you aware of this thing called the Pythagorean Theorem. The Pythagorean Theorem applies only to right triangles. Right triangles are triangles that one of the interior angles is 90 degrees. So this is a little kind of ugly little illustration of what a right triangle looks like. And what the Pythagorean theorem says is that the length of the horizontal squared plus the length of the vertical squared equals the length of the diagonal squared. Yeah, and this little result has a lot of applications for us. It makes it a little bit easier to graph things once you kind of recognize that they are just inside a right triangle. So the horizontal leg, the length of the horizontal leg squared plus the length of the vertical leg squared equals the length of the diagonal leg squared. So a squared plus b squared equals c squared. That's the Pythagorean theorem. Okay, now we're going to use this Pythagorean theorem quite a bit in this little second part of this section. So I want to know how to find the distance between 2 points. Yeah, so imagine that they give me 2 points. They gave me the point x1 comma y1, which is it's this point down here. They gave me another point x2 comma y2, so they have different coordinates. The little x1s, the ones and the 2 here, those little subscripts are just to kind of denote that they're different values. So I was given 2 points, the point x1 comma y1, and I was given the point x2 comma y2. Okay, and so then imagine a straight line between these 2 points. And right now what I want to know is what's the length of that straight line? How long is that straight line? So I'm calling that length d over here, so d. I want to know the distance between the 2 points, the length between the 2 points. Okay, well, I'm going to use the Pythagorean theorem to answer that. And if you notice here, what I sort of did was kind of draw a little bit of a little triangle, a little right triangle. And if you notice this horizontal length, the horizontal length is the difference between the x coordinates. So x2 minus x1, that's the horizontal length. The vertical length of my little right triangle is the difference between the y coordinates, y2 minus y1. Okay, so I know this horizontal length is x2 minus x1. I know the vertical length is y2 minus y1. And now I'm just going to apply the Pythagorean theorem. So the Pythagorean theorem says that d squared, this diagonal, equals this horizontal length squared plus this vertical length squared. And then what I'm going to do is, since d is the length that I'm interested in, it's the length of the line between the 2 points, I'm going to take the square root. And this equation right here in red gives me the length or the distance between 2 points. So if you give me 2 points, x1 comma y1 and x2 comma y2, this little equation gives me the distance between them. And all it is just really the Pythagorean theorem. Okay. Another little application that we're going to need here is how to find the midpoint. So if you give me 2 points again, so you gave me the point x1 comma y1, and you gave me the point x2 comma y2, and now imagine the line that joins them, so the straight line that happens to go through both of those 2 points. So envision the straight line that happens to go through both of those points, and now try to think about the middle of that line, the exact middle of that line, the point that splits that line in two. Well, right now I'm just calling it a comma b. I mean, it has some coordinates. turns out that the coordinate, the x coordinate of the midpoint is the sum of the other two x coordinates divided by 2, and the y coordinate of the midpoint is the sum or the average kind of the two y coordinates. So the distance between 2 points is going to be some value, something like 3.8. The midpoint between 2 points is going to be another point, so be careful with that. The distance is just some number, the midpoint is an ordered pair. And these little equations, this one right here in red, this is my formula for my distance. This little ordered pair here in red is kind of the template for the midpoint. Okay, so let's get into a little exercise here. What we want to do is we want to find the distance and the midpoint between the two following points, -4, -3 and 5, 6. So pause the video, take a couple of minutes, try to find both the distance between this point and this point, and also find the midpoint between the points. Okay, so let's see what we can do. Let me first get into the distance. Let me try to, well, actually what I'm going to do is I am going to just plot the points first of all. So -4, -3. This point right here is in the third quadrant. It's right there. That's my point, -4, -3. I've just plotted it. I went to the left 4, down 3. I'm going to plot the point 5, 6. So 5, 6 is just right there. So those are my 2 points. And right now, what I'm interested in is the line that happens to go through both, or yeah, think about the little line that kind of joins both of these 2 points. Let's see, can we make a little line that joins those 2 points? Something like that. Okay. So that's what I'm dealing with right now. And so let's find, first of all, we're interested in the length of this line. Let's find that. So according to my distance formula, the length is going to be, it doesn't matter which one you called x1, y1, x2, y2. It does not matter. I could have called, you could reverse it. This could be x2, y2, this guy x1, y1. It doesn't matter. Just be careful with your signs. So right now I'm just going to read it from left to right. So I'm going to say this guy is x1, this is y1, x2, y2. So I'm going to do 5 minus, now I have to be careful here, -4, be careful with your signs. And all of this is squared plus, then I have 6 minus -3 squared. Again, be careful with your signs here. Think about what I did. So I said this is my x2, 5. So 5 minus, this is my x1, 5 minus -4. So 5 minus -4. Notice that I put a little parenthesis around my -4. Yeah, and if you're thinking this minus becomes plus, they do. They absolutely do. And again, keep order of operations in mind. Please excuse my dear Aunt Sally. So take care of parentheses first, brackets first, then exponents. Alright, so it looks like I have the following. So this 5 minus -4 actually becomes 5 plus 4. So that becomes 9 squared plus, and then this 6 minus -3, that's like saying 6 plus 3, so that's also 9, so plus 9 squared. Okay, and oops, this is underneath the square root, and so this becomes 81 plus 81, and so then that's, I guess, 2 times 81, which is what, 162. 2 times 81, 162. This is the exact this is the exact answer. So this is exact. Now we could simplify it a little bit. Let's see. We could think about, so let me think about perfect squares that divide 162. Well, I guess 9. I mean, this is the same thing as saying this. So this is the same thing as 81 times 2. 2 times 81. And then what ends up happening is that the 81 is a perfect square. So this 81 is a perfect square. So you can bring it outside of the radical and it becomes a 9. So this becomes 9 root 2. So this is our exact solution. This is in simplified form, 9 square root of 2. That's probably what my math lab would prefer rather than the square root of 162. So do get used to simplifying your radicals. And if we do the square root of 162 in a calculator and we round to the nearest 3 decimals, let's see what we get. Square root of 9, square root of 2, I get about, so here this is approximately, I'm going to use this squiggly little equal signs for approximately, it's 12.72, and then my calculator says 79, but right now we want 3 decimal places, yeah? So how do I round to 3 decimal places? What I'm gonna have to do is, well, here's the 3rd decimal place, and that guy is definitely closer because the one afterward is 9, so this is closer to 8 than it is just to itself. So I'm gonna say that this is 12.728. Alright, so that's exact, and this is rounded. Okay, so that's the distance. I don't know what we're measuring things here in. It could be inches, it could be feet, it could be meters. It doesn't matter, some units. Okay, so that's the length between my 2 points. Now let me find the midpoint. Let me find the midpoint. So the midpoint is a point, and it's going to go, well, its x-coordinate is going to be the sum of the x-coordinates. So -4 plus 5 over 2, comma, its y-coordinate is going to be the average of the y-coordinates, -3 plus 6 over 2. Okay, let me simplify this a little bit. So this becomes 1/2, and the other one becomes 3/2. So this is my midpoint right here. This is my midpoint. And now let's see, if I was to plot that, so 1/2 is my x, and then 3/2, so like 1.5. Yeah, that looks about right. I mean, I mean, think about it. So 1/2, that puts me right there, and then I have to go up 1.5. That looks about the midpoint. I buy it. Okay, so hopefully this is okay. How to find the distance between 2 points, and how to find the midpoint between 2 points. Definitely simplify your exact answers. So for instance, here we had this square root of 162. We notice that 162 is the same thing as 2 times a perfect square, 81, and so then perfect squares can come outside of the square root as their square roots. The rounded form here is 12.728. Okay, let's move on. Let's talk about the equation of a circle. Yeah, so let's think about a circle. So here I drew a little circle. It has what's called a center. The center is the middle point of my circle. In this case, I made sure I gave it coordinates. It's x coordinates, so here's the origin of my Cartesian plane. So I went h units to the right, and I guess I went k units up. So this point right here should have coordinates h comma k. Yeah, so let me write that down. So this is the center. The center has coordinates h comma k, and another thing that the radius that the circle has is this dimension called a radius. It's the distance from the center to any point on the circumference. So that length from the center to any point on the circumference is called the radius. So radius r. So right now what I'm dealing with is a circle whose center is at the point h comma k and whose radius is r. And I want to come up with an equation for such a circle. First of all, so if you think about it, I'm really interested in all of the points on the circumference of the circle. So so think about any point on the circumference. The circumference is just kind of like the outer wire of the circle, the perimeter of the circle. If you pick a point on that, pick any point on the circumference of the circle, well, what ends up happening is that the distance between that point and the center, the length is r. If I pick any other point over here, let's say, the length between this point and the center should be r, the radius. Okay, and so I'm going to pick a point on the circumference. I'm going to call it x comma y. It's just any point. It has x coordinate and a y coordinate. And notice here that what we did is we drew a little right triangle. Yeah, and so then I drew a little right triangle, so the Pythagorean theorem kind of applies here. This horizontal length now, the horizontal length, is going to be the difference in the x's. So this x minus this x coordinate minus the x coordinate of this point. The x coordinate of this point is h. So x minus h is the length right here. Because if you think about it, just right around there, that's where my x would be. And somewhere up here would be where my y would be. Okay, so this little horizontal length of this little right triangle is, the length is x minus h. The y length, or the vertical length, is y minus k. And now I have just a right triangle. The diagonal, the length is r, the radius. So the Pythagorean theorem just says that r squared is equal to the horizontal length squared plus the vertical length squared. And it turns out that this is my equation of a circle. This is the equation of a circle centered at the point h comma k with radius r. Yeah, so this is worth kind of keeping in mind. Okay, let's see. Let's practice this. Again, notice that this is a non-linear equation. Here I have my variables x and y have exponents on them, and so this is definitely non-linear. I mean, it's a circle. Okay, let's get into some examples here. So I want to find the equation of a circle with radius 4 and the center at -1,3. So right now you're supposed to come up with the equation. So pause the video, take a minute, try to come up with the equation that's necessary here. Okay, so let's see, what's the equation that I need here? So they told me that my r is equal to 4. They tell me that the center is -1,3. So let's come up with the equation for this. So it's going to be 4 squared. I'm literally just looking over here. So my radius squared equals x minus the x coordinate. H is the x coordinate. It's the x coordinate of the center. So I guess x in this particular case minus -1 squared plus, and then I have y minus the k is the y coordinate of the center. Well, in this case the y coordinate of the center is 3. Y minus 3 squared. Okay, so then this becomes 16 equals, here be careful with your signs, x minus -1, well that's like saying x plus 1. So x plus 1 squared plus y minus 3 squared. And that is the equation that we should have gotten. So this equation right here represents a circle centered at -1, 3 with radius 4. So yeah, the signs of the center, sort of the signs of the coordinates of the center change, and the radius gets squared. Okay, so hopefully you were successful at coming up with this equation. Let's think about the next little example. The next example asks us, which of the following is an equation of a circle in the coordinate plane with center 0, 4 and radius with endpoint 4/3, 5. This is kind of, so pause the video and definitely try to give this a shot. See if you can understand what the question is asking us. And let's see what the correct answer is here. Okay, well, let's see. Let's try to answer this. Hopefully you already got an answer and you know which is the correct option here. Let's see if we agree. So I'm gonna try to sketch a little something, yeah? So my center, so the center of this circle is supposed to be the point 0, 4. I'm gonna pretend right there. So that's 0, 4. Yeah, that's the center. And it told me that it has a radius with endpoint 4/3, 5. So 4/3. 4/3 is what? It's something like 1.33333, something like that, and 5. So I'm gonna pretend. So this is 4. I don't know. Let's just pretend that the radius is right there, 5. So I have something like this. So this point right here is supposed to have coordinates 4/3, 5, and this is the point 0, 4. 0, 4. Okay, so that's what's going on here. That's what they gave us. And so then we need to find the length. That's my radius right there. Yeah, that is r. And we need to find the length of the radius. Or rather, we just need to find the radius. So we need to find the radius. How do we do that? What do you suppose we would have to do here? So what we were given is the center and some point on the circumference, and while the radius is the length of the little line that joins those 2 points. So good thing we have a distance formula, because right now we're going to have to use it in order to figure out what r is. So right now what we want to say is that r, so r is the length, or it's the radius, is going to be, we said it's the difference of the x coordinates. So right now I'm using the distance formula. Right now I'm using my trusty old distance formula over here. I need it right now to find my radius. So right now I'm gonna say it's 4/3 minus 0 squared plus, and then I'm gonna say 5 minus 4 squared. Okay, well that becomes 4/3 squared plus, this becomes just 1 squared. So that is the square root of, this becomes 16/9 plus, I guess, 1. And so then that becomes 16/9 plus 9/9, because we are adding fractions, so we need a common denominator. So that is the square root of 25/9. Yeah? So that's my radius. So now let's see if we can put this together. So the equation of the, so right now I'm supposed to come up with the equation of a line, sorry, the equation of a circle whose center is at 0, 4 and has a radius with endpoint this point. So that tells me that the length of the radius is the square root of 25 over 9. So let me kind of see if I put this together, and then I'm going to choose the correct answer here. So I'm going to say x minus 0 squared, because it's x minus the x coordinate squared, plus y minus 4 squared equals, and then my radius, we figured out what the length of the radius was. The length of the radius is the square root of 25 over 9, but then we have to square that, don't forget that, so be careful. Yeah, and well, then yeah, x minus 0 squared, that's just like saying x squared. And then y minus 4 squared, well, we'll just keep it as is, y minus 4 squared. And now, what happens if you square a square root? They're kind of inverses of each other. So then the square root goes away, and also the exponent too goes away. So this just becomes 25 over 9. So be careful here. The square root is gone because we have to square it. So I think this is the equation of the circle that we want. So now what is that? What choice should we make then? I think our answer is A. I think our answer is A. Alright, so hopefully we agree on this. Alright, last little exercise in this. Let's graph a circle. So we are supposed to graph this circle. It's x plus 2 squared plus y minus 2 squared equals 9. Yeah. So let me first identify about this. What is the center? Again, you should probably pause this video and try to graph it on your own. And the first two things that you should ask yourself is, what's the center of my circle? What's the radius of my circle? Once you have those two pieces of information, then it becomes easy to graph the circle. Alright, so what's the center? I need to know that. What's the radius? So the center is going to be, this is the, you have to change the signs. So this becomes a negative 2, because it should be x minus negative 2, that makes it into plus. So my center is negative 2, comma 2. And what's my radius? How do I find my radius? Well, I'm looking at this 9. I have to take the square root of that 9. So my radius is 3. Now that I know this, it's easy to graph, because now it's just negative 2, comma 2. So that's right there. And this circle has radius 3. So I have to, from here, I have to go 3 units to the right, 3 units to the left, 3 units up, 3 units down, and something like that. You get the idea. That doesn't look very circular at all, but you know, that was my best attempt at a circle. Okay, so that's it for 1.1. This is a little intro to graphing equations. Thank you, and I'll see you in the next video.